All right, class, so this is an ALEKS topic called identifying Lewis acids and bases in reactions. And before we can do this topic, really what we need to do is we need to go over the different definitions. So here are my acid-base definitions. So a Bronsted acid and a Bronsted base, we said that those are going to be more of the proton, we're thinking about the proton movement. So a lot of this acid-base chemistry that we're doing in chapter 15 is going to be talking about proton movement, right? Weak acid, weak base, what's going to be moving, how we're going to tell the difference. It's all about that proton moving around. So proton donor giving H plus is going to be the Bronsted acid. Proton acceptor, where that H plus goes, right, is going to be that Bronsted base. Now, another way to think about acid-base chemistry is this Lewis sort of definition. And in a Lewis acid, we're going to be looking at it from the point of view of the electrons. So it's going to be sort of opposite of the Bronsted acid. So a proton gets donated, right? A Lewis acid, an electron pair is going to be accepted. So if we have something that's going to, form a new bond, and we'll look at some examples in just a second, the electrons are going to be what we're focused on. Whereas the focus for Bronsted is on the proton being moved around. The focus for Lewis is going to be the electrons and what's going on with the electrons to form new bonds. So electron pair acceptor, Lewis acid, electron pair donor is going to be the Lewis base. So let's get into some examples and we'll see sort of how these sort of come to play. So this first reaction, this is going to be a very classic Lewis acid base situation. So I've got a metal, so zinc 2 plus, a metal ion, and then I'm going to be reacting with this sort of organic thing. And we're actually going to end up calling this a ligand, but that's sort of down the road. Don't worry too much about that. And we're going to be forming this complex ion here. So we've got metal, we've got all of these that are bonded to the metal. So there's going to be a chemical bond between this complex and the zinc. It's actually going to be through the nitrogen. So the lone pair of electrons on the nitrogen is going to be bonding to the zinc. So that's going to be a new bond. So this question is asking us, in terms of this highlighted reactant, the CH3CN, what's going to be going on here is a lone pair of electrons on nitrogen are really going to be donated to that zinc 2 plus to form that complex ion, to form this new thing here. These need to be stuck to that zinc 2 plus. So this guy right here, or gal, right, is donating that pair of electrons to the zinc 2 plus. So if we look at what our definitions are, a Lewis base is going to be doing the electron pair donating. So Lewis base, electron pair donor, that's what this CH3CN is acting as, a Lewis base. It's not a Bronsted-Lowry acid or Bronsted-Lowry base because there's no H plus, right? We don't see a movement of H plus anywhere in this reaction, so we're just going to look at the Lewis definition. Same thing here, right? So in this one, I've got nickel 2 plus. I'm going to be forming this complex ion. These NH3 molecules or ligands are going to stick to that nickel 2 plus, and the same sort of electron pair donating will be happening here. So this is also going to be a Lewis base. Finally, we get to that H plus that we're used to. So here we've got a weak acid, HCN, reacting with a weak base, CH3NH2, to give us that conjugate base of HCN, and then the conjugate acid of this CH3NH2. So this is more like what we're used to seeing here in chapter 15. And in this case, this is going to be a Bronsted-Lowry base. So it's hard to keep straight, right? This is going to be accepting the proton. So it accepts the proton to form this, right? So this would be the conjugate base, conjugate acid. Make sure that you're comfortable with those terminologies. And it's also going to be a Lewis base. So if it's a Bronsted-Lowry base, it will always be a Lewis base because it will also be sort of accepting or donating the pair of electrons. So the pair of electrons in this case that are going to be donated are, again, on that nitrogen. We could think of those electrons going and forming a new bond with the hydrogen. So we see that this would also be acting as a Lewis base. So something can be both a Bronsted-Lowry base and a Lewis base. That's pretty common. In these cases, it's not acting as a Bronsted-Lowry base because there's no H+. Let's do a few more examples. So on my next sheet here, we've got just same question, just a few more examples. So here I've got a sort of tricky one. You're going to run into this every once in a while. I've got H2, and then I'm forming HCl. So the H bond is essentially being sort of replaced by an HCl bond. They're giving us this in the gaseous phase. This doesn't fit any of our definitions. So if you see something like this and you're a little confused, if it doesn't fit the definition, if we're not seeing a reaction like this or a reaction like this, then don't fill anything out. This is sort of a trick question. I'm not a super big fan of this, but we're not going to fill any of these. Check all that apply, none apply. In this case, again, we see the sort of similar thing as we saw before. lone pair of electrons on nitrogen going to be donated to the nickel. This is going to be a Lewis base. And here again, we've got that sort of weak acid, weak base thing. This is going to be a Bronsted-Lowry base and a Lewis base because it's going to be accepting H+, right? So we're going from NH3 to NH4+. So we've got a movement of H+, so it fits the Bronsted definition. And then we can also always sort of think about it in terms of the lone pair of electrons that's being donated to take that H+. If you're going to be selecting Bronsted-Lowry and Lewis, you should be selecting the same thing, right? It's not going to be a Bronsted-Lowry acid and a Lewis base. They're always going to be the same, both bases or both acids. Let's do one more. So in this last set, we've got here, I'm seeing we're going from HO, NH2. We're accepting a proton. We're going to a conjugate acid here. So that tells me this is a Bronsted base and a Lewis base. Here we've got a donation to form a new bond between the CO and the nickel. So this is just going to be acting as a Lewis base. And then the last one here, NH3, again, doing this sort of similar thing up here. We've got a metal, we've got a non-metal sort of ligand sticking to that metal, and we're going to be acting as a Lewis base here. If these Ag plus or nickel, if those were the ones that were highlighted, those would be the Lewis acids, right? I don't think we ran into any examples of Lewis acids, but it's just the opposite, right? It's just the opposite of the NH3 this would be acting as a Lewis acid. This is going to be the Lewis base. So it's accepting that electron pair. All right, hope that helps.